Replacing two fan motors for the condenser on a KKT Kraus chiller. I'm currently sitting on top of the equipment. Nice view, beautiful day, beautiful sunny day. A little bit of a risky business because you can see there's not much space to work. I'm sitting on one of the motor that I'm going to be replacing, old motor that is, and I'm currently started on the other one already. There are the two new ones right there sitting there. All right, so yeah, probably most of you guys will never do this because it's a German chiller, or it's not something that's used widely across our industry. This is for medical use, like primarily MRI and scanning equipments. But anyways, so far a problem that I've run into is these bolts that holds the motor in place. See the brackets right there? That's the mounting brackets on the side. So they are not. I couldn't use my DeWalt impact with my bit setup, all the different assortment of bits on there, or different assortment of chocks, whatever you want to call that. I don't know. Right, I got several different sizes here, but that didn't work because it's not a I guess it's metric. Of course, because it's from Germany. All right, so this is a 10mm. That works perfect. I happen to have that in my bag, so yeah, that saved the day. But let's talk about the wiring of this motor real quick, because that's I'm up to that part right now. The wiring is pretty straightforward. Here's a schematic. I'm going to be doing some short clips. You're going to be seeing some short clips in this. I mean, I guess it doesn't make sense because you'll be watching the videos anyway. But anyway, yeah, you can see we got delta and star, or delta and Y configuration. All right, how do you figure that, right? So they're telling you here that delta, we are at is that low speed? Is that what it's saying? Yeah, no, that's high speed. So delta is high speed and Y is low speed. And it makes more sense because Y, you'll have all the windings lined up in series, so more resistance and less amperage draw, and so you're going to be, you know, lower speed. Delta configuration, more than likely you're going to have the wires now. The wires is going to be in parallel. That's pretty much what it's going to be. It's going to be in parallel. So the windings are going to be parallel. So now the parallel windings is going to be more amperage, more work, more amperage equal more work, higher speeds. But in this case, I have a VFD. There's a VFD on this chiller. Not I have. The chiller has a VFD. So I'm assuming with that said, they're wiring it up in a high speed, which is delta. So they're using U1, V1, and W1. You can see line 1 right here, and line 2, and line 3. The wires is marked, which makes it easy. And then these two, it's already shunted. But these two are supposed to be for the thermal switch in this motor. There's a thermal switch in there. If it overheats, it's going to open. I can see that right there towards the end. Where it says TK, and TK. That's your thermal switch. All right, TK and TK. Does it say it in the legend? I don't see there, but yeah, TK and TK is your thermal switch. If the thing overheats, it's going to open. So right now you can see this one is shunt or bypassed. I guess this motor was well on its way, so someone bypassed. I think it was me. Was it me? Maybe it was me. I don't remember. Nonetheless, the next thing you want to, if you happen to be doing this, and the rare occasion you happen to be doing this, if you get any water in here, this motor is going to be toast. Now, this is 460 volts. All right. and any water down here is going to be toast. You can see clearly. All right, these are the leads going into the motor. I didn't talk about the jumpers, but I don't have to talk about the jumpers around here because there's 1, 2, 3 jumpers, and like you see right here, it's in the delta. So you see that's where the jumpers are. 1, 2, 3 loops. Y2, W1, U2, V1, and W2, U1. Yeah, they're all shunted or jumped. You three jumpers right here. And obviously, if you're going to do it in a Y connection for low speed, then you wouldn't. You'd have a different configuration. You see where it's wired up over here, all right? Where you got W2 and U2 and V2 jumped or shunted together, and line 1, line 2, line 3 is that's U1, V1, and W1. All right, is it the same over here? U1, V1, yeah. So yeah. Line 1, line 2, line 3 is always the same. U1, V1, and W1. Yeah. So on these type of chillers, I've seen it where the motor will utilize both high and low speed based on what the chiller is doing and based on the outdoor ambient. So, but how they accomplish this is by using 3 contactors. So I'm assuming, let's see what they would wire that with 3 contactors. So obviously, if you want high speed, then you would engage the high speed contactor, disable the low speed contactor, and then you'd have a contactor that's doing the shorting. Maybe it's going to be 4 contactors, not 3 contactors. But I've seen it where they use contactors to switch between speeds, you know. So they use a contactor to create the jumps or the shorts between the different modes, and then, you know, if you have the wrong combination pulled in, it's a dead short. Okay, so obviously, yeah, so line 1, line 2, line 3, that could be shared by either the same contactor, basically. The same contactor. One contactor bringing line 1, line 2, line 3, one contactor, and then another contactor is going to be a jumper between K2 and say U1, and then U2 and V1, and then V2 and W1. And then that's going to be your high-speed contactor, right? So you're going to bring in your main power contactor. It's going to bring power to L1, L2, L3, and you're going to bring in your high-speed contactor, which is going to be like you're going to have one wire coming from W1 and one wire coming from U2, another wire coming from V2. I don't want to make this video long and stretch because of explaining this wiring stuff, but I mean, if you know, you know. I mean, I'm just gonna stop right there. All right, let's go. All right, so yeah, so you gotta be careful with this. So you know, I had to break this, loosen this nut, this thing right here, this nut right here, and then so that I could spin this around, easy to unthread it. Because again, if any water comes in here, you're toast. This thing is gonna be short-lived. All right. Same thing. I'm gonna loosen this right here. Grab my adjustable wrench. That doesn't fit. Does it fit? No, it doesn't fit. Okay, this one fits. Alright. So I can easily go and disconnect the wires in confidence, or with confidence, because I know how it's laid out. Is it the whole thing is turning or not? Yeah, no. It's okay, so I'm unscrewing that. I'm unthreading that. Alright, so now with that said, with that loose, now I can pull this a little bit out like so, and then I can loosen this piece right here. So you want to watch me work. Is it biting good? Ain't got much to play with. think I'm good. Not good. Let's try this now. Man, this thing is tight. Wow. Okay, I gotta put this camera down. Yeah, that thing was pretty tight. So I had to like use both hands and like bang the wrench. So I hold it with one hand and bang it with the other. So I give it like an impact hammering effect. Hammering away. Alright, so that's that. So that's pretty much straight. It's gonna pull these wires out. I mean, I have the powers already off from the drive. So if we get down there and give you guys a view. Like I said, this one has a VFD drive. The power is off. Ain't no power cord. This is already dead. I have the switch off, even though the chiller is still running. So the other circuit is running. This circuit, these motors, I flip that switch, it's dead. Okay, make sure you turn the powers off before you start working. Yeah, got rust on my tools. But anyways, yeah, that's it. So now I'm just gonna simply pull these out. I already got these screws, the mounting screws, 10mm. It's ready to go. It's gonna pull these. Got my screwdriver right here, my client, and this is the tools you're gonna need. Something like that. You're gonna need this, because this right here, as you can see, is plastic. So I gotta hold it gently and loosen it with this, because obviously the wrench would have been sliding around the plastic, because it was really tight. All right, yeah. So I'm just gonna loosen the wires right now. 1, 2, 3, and then these two, and just gonna take them out and then drop the new one in place. That's it. All right, so there you go. It is out, all disconnected. I put a little bit of tape on this because we might have 24 volts DC here, and we don't want to short anything out. So, but these are definitely dead. That's for sure. The line voltage. All right, so we're disconnected. Just gonna remove this bad boy. Let's lift it out of place. And obviously I can't hold the camera while doing this, because you can see where I'm at. I'm sitting up high, baby. All right, so I'm gonna take this out, drop one of those in place. I'll be right back. Here we go. So I'm just gonna open this up real quick. Covers. I mean, you guys don't need to see me do this. I'm gonna open it up, just see the wiring, and then you know, pull this plug out, take this dummy one out, because I'm gonna have to put 2 connections, one on each side. I mean, pretty straightforward. Motor information, made in Germany. Okay, I'm gonna come back once I open this cover and have the wires attached so we can wire it up. Okay, so now that we're all reconnected, it's gonna terminate all my wires now. Got ground right here. Goes to the grounding screw right there. This is also grounding screw. And so yeah, you know how the wires goes already. Here's a new schematic wiring diagram. It already comes out of the box from the factory in the Delta configuration, right, as it was on the previous one, the older motor that I removed. Okay, so yeah, just gonna put the wires back. It's pretty straightforward. I ain't gotta go through that for you guys. I mean, if you're watching this video, you better know to put some wires on the terminal. All right, I mean, and you saw how I remove it, right? So these two, it's gonna go right here. You know, your terminal switch. They have the TB. As a matter of fact, is it different from over here? What is it called? Over here they call it TK. There's a TK over here, and over here is TB. Okay, there's a little bit of difference, but anyway, it's the same thing. Goes right here. These two goes right there. 1 and 1. And what else? So the power wires. Number 1 that came from U1. Same thing. The power wires. Line 1 goes to U1. Line 1 goes to U1. Line 2 V1, and line 3 W1. Okay, same over here. U1, V1, W1. Same thing. The only difference is TK, and obviously it says TB here. That's it. All the same, except for that. All right. So yeah. That's where it's at, guys. Terminate my wires. I'll show you the finished product, and obviously I gotta put my screws back, which is that's easy enough. Just lined up. That's one. And these are number 10 millimeters. 10 millimeters. If you're wondering how the hell am I doing all this in the glove, these are the best gloves. Actually, I'm gonna do a video. I'm gonna do a quick video about these gloves right here, because I was on a journey for gloves and my hands was getting murdered. Right, while I'm working. You guys in this industry, you know, your hands and fingers get murdered daily. So, and then you'll be taking your gloves off because you can't work, you can't feel nothing. Yeah, but you see I'm wearing these gloves in everything I'm doing. I don't even take it off to touch my phone. Now these gloves are epic. Alright, I'm gonna do a video on this, talk about these gloves, what they are, what they can do. You see I'm just doing these screws right here? So easy. I'm doing all this wiring, everything with my gloves on. Don't take it off, from start to finish. Someone calls me right now, these things are staying in my hand. Alright, I'm gonna put these wires in real quick. I'll get back. German chiller and German fan motor. So I added some tape as an extra insurance because these fittings are old and don't want any water again to this bad boy right here. So that is it finished. Product.